Neptune is one of the most mysterious giants in our solar system, a world so distant, cold, and enigmatic that even today it feels more like a myth than a planet. When we talk about Neptune, we are not just talking about a simple sphere of gas floating in the dark. We are talking about the limits of our solar system, the edge of sunlight's reach, and a world that challenges what we think we know about planetary science. This script begins by taking the viewer on a journey across the vastness of space, explaining how Neptune exists as a silent, deep blue sentinel orbiting far beyond the familiar bright dots we call planets. To understand Neptune is to understand extremes, the harshest winds, the coldest atmospheres, the longest orbits, and the deepest mysteries of the outer system. Every discovery about Neptune feels like unlocking a secret hidden in the cosmic shadows, and this video dives into these secrets with cinematic storytelling, scientific accuracy, and a sense of cosmic awe. Imagine starting the video by drifting away from Earth, leaving the moon behind, passing Mars, sweeping across the asteroid belt, and sliding past Jupiter and Saturn. The giant worlds fall behind as we go farther out than Uranus, deeper into the solar system's frozen frontier. The sun shrinks into a bright star, and the glow around the spacecraft fades. At last, a small bluish pinprick of light appears. That point of light gradually expands into the magnificent azure sphere of Neptune, the eighth and final major planet of our solar system. The narrator's voice describes how Neptune was the first planet ever discovered using mathematics rather than telescopes, a testament to human curiosity. In the early 1840s, astronomers noticed that Uranus was not orbiting exactly where it should. It was being tugged by an unseen giant. Two mathematicians, John Couch Adams in England and Urbain, Leverrier in France, independently predicted where this hidden world must be located. On September 23, 1846, the planet they had calculated appeared almost exactly where Leverrier said it would be. This discovery was more than scientific brilliance. It was proof that human minds could reach across billions of kilometers and find a world without ever seeing it first. The video transitions to a slow rotation of Neptune, showing its deep and hypnotic blue color that sets it apart from all the other planets. This rich blue comes from methane in its upper atmosphere, which absorbs red light and reflects blue. But that's not the full story. There is something else, something not fully understood. Neptune is bluer than Uranus. Even though both contain methane, this suggests that Neptune has some component or chemical interaction that scientists have not fully identified, reminding us that even basic aspects of this world remain a puzzle. As the camera glides across the cloud tops, we see swirling storms, bright methanized clouds, and ultra-high-speed winds. Neptune is wild. Winds can reach more than 2,000 kilometers per hour, the fastest in the entire solar system. The narrator explains that no one fully understands how winds can move so quickly on a planet that receives so little sunlight. It might be internal heating, atmospheric layering, or something about its chemical composition. Yet it is another mystery of the blue giant. Neptune's atmosphere is made up of hydrogen, helium, methane, and possibly deeper layers of hydrocarbons, ammonia, and water vapor. If we could ever dive into Neptune, the narrator explains, we would pass through clouds and descending pressure until reaching a region where water exists in an exotic state known as suprionic ice unelectrically, conductive form of water that behaves like a crystalline solid and a boiling fluid at the same time. Scientists believe suprionic ice may form an ocean-like mantle around Neptune's core, generating a strange magnetic field that is tilted, lopsided, and offset from the center. The magnetic field flips and twists in ways completely different from Earth's, showing how alien this world truly is. As the video continues, it transitions to the Great Dark Spot, a massive storm system discovered by Voyager 2 during its historic flyby in 1989. The only spacecraft to ever visit Neptune, the narrator builds cinematic tension by showing the immense swirling vortex. A storm the size of Earth, with winds faster than a jet aircraft. Voyager 2 only had a few hours near the planet, but those hours changed everything. It captured Neptune's rings, moons, storms, and structure in more detail than anyone expected. Yet even today, Neptune remains largely unexplored. Since Voyager 2, no spacecraft has returned, leaving many questions suspended in silence. Later observations from the Hubble Space Telescope revealed that the Great Dark Spot had vanished, only for another dark storm to appear elsewhere. This suggests that Neptune's atmosphere is dynamic and unpredictable, a world of storms that appear and disappear like cosmic ghosts. The script then shifts to Neptune's rings, which are thin, faint, incomplete arcs of dust and rock. Unlike Saturn's bright and majestic rings, Neptune's are shadowy and subtle. They have clumps called ring arcs, strangely stable structures that should not exist. Yet they do. The narrator explains that scientists believe gravitational interactions with Neptune's moon, Galatea, may keep these arcs from dispersing, but the details remain obscure. These rings serve as another reminder that the outer solar system often defies expectations. Speaking of moons, Neptune has 14 known moons, and the most famous by far is Triton. The video transitions to Triton by zooming slowly into its surface, showing frozen plains, nitrogen geysers, and a world that moves in the opposite direction of Neptune's rotation, a rare trait called retrograde orbit. This retrograde motion suggests that Triton was once a dwarf planet in the Kuiper Belt, captured by Neptune long ago. This capture would have been violent, perhaps causing the destruction of Neptune's original moons and reshaping its entire system. Triton is more than a moon. It is a world with an atmosphere, icy volcanoes, and the potential for a subsurface ocean. The narrator explains how nitrogen geysers shoot dark material across Triton's surface, creating streaks that Voyager captured decades ago. Scientists think Triton may even support a warm ocean beneath its frozen crust, making it one of the most intriguing candidates for extraterrestrial life in the outer solar system. For a moment, the script slows down to contemplate this possibility that even in the coldest corners of our solar system, hidden oceans may support environments unlike anything on Earth. Zooming back out, the narrator brings attention to the fact that Neptune takes 100 Earth years to make one orbit around the Sun. This means that since Neptune's discovery in 1846, it has completed only one orbit. The first in human history, in the year 2011, Neptune's seasons are long and slow, each lasting over 40 years. The tilt of Neptune's axis, similar to Earth's, means that despite its distance from the Sun, it experiences seasonal changes. However, these changes are subtle, shaped by a world where sunlight is incredibly faint. At Neptune's distance, sunlight is 900 times weaker than on Earth. The narrator compares this to standing in the shade on Earth versus standing under Neptune's sunlight. They feel almost similar, showing how dim our star becomes at this enormous distance. The video now explores Neptune's internal heat, which is surprisingly strong. Neptune emits more than twice the heat it receives from the Sun. Something inside Neptune is producing enormous energy, possibly from gravitational compression, radioactive decay, or internal layering that traps heat. But again, there is no clear answer. Neptune is a paradox, the coldest giant with the wildest winds, powered by a heat source that defies simple explanation. This tension between cold and heat is one of the reasons Neptune is such an enigmatic world. Next, the narrator takes the viewer into the realm of hypothetical missions to Neptune. Scientists have long proposed orbiters, landers for Triton, atmospheric probes, and flyby missions designed to finally reveal Neptune's secrets. Every mission concept emphasizes the potential for groundbreaking discoveries. Understanding ice giants, learning about exoplanets because most discovered exoplanets are Neptune-like, and uncovering the history of the solar system. Yet, Neptune remains ignored in favor of missions closer to Earth or missions to Jupiter and Saturn. The narrator creates suspense by suggesting that Neptune is the next frontier waiting for humanity to return, a world with unanswered questions that hold cosmic importance. As the script reaches its midpoint, attention turns to the broader significance of Neptune. Ice giants like Neptune and Uranus appear to be the most common type of planet in the galaxy. So understanding Neptune is not just about knowing our own solar system, it's about understanding the universe. The video dives deeper into comparisons with explaining how Neptune-like worlds are found everywhere and often in unexpected locations, such as extremely close to their stars. These hot Neptunes challenge planetary formation theories and again connect back to why studying the real Neptune matters so much. The script becomes more reflective at this point, describing Neptune's symbolic role in human culture. Named after the Roman god of the sea, Neptune embodies an ocean of mystery. Its color resembles the deep ocean on Earth, and its swirling storms look like tidal whirlpools. This metaphor helps the viewer emotionally connect to a world they will never visit, imagining Neptune as a cosmic ocean drifting in darkness. The narrative shifts into a detailed exploration of how Neptune has shaped our understanding of the Kuiper Belt and trans-Neptunian objects. Neptune's immense gravity shepherds and scatters these icy bodies, controlling their orbits and influencing the structure of the outer solar system. Some objects, like Pluto, have orbital resonances with Neptune, meaning they dance in stable patterns that prevent collision. The narrator describes this dance as graceful and mathematically precise, as if the solar system itself performs a cosmic choreography under Neptune's influence. Now, the script returns to Triton for a deeper scientific discussion. Triton's retrograde orbit tells a story of cosmic capture. Its surface shows active geology, and its interior might harbor an ocean. The narrator wonders how many secrets are locked beneath its icy shell, questioning whether its strange landscapes hide chemical processes that could support simple life. Triton's connection to the Kuiper Belt also means studying it is like studying a preserved fossil of the early solar system. The video then transitions into a more philosophical tone, pondering why Neptune fascinates us so much. Perhaps it is because Neptune represents the unknown, the unreachable, the part of the universe that remains untouched by exploration. It stands as a marker of our limits, but also as a symbol of future possibilities. When Voyager 2 flew past in 1989, human eyes saw Neptune up close for the first time. That moment proved that even the most distant worlds can be reached. But since then, silence has returned. Neptune waits, unchanged, distant, and patient. As the script enters the final section, it describes Neptune's place in the grand narrative of human exploration. The spacecraft that discovers Neptune's deep atmosphere or lands on Triton might not even be launched for decades. But the idea drives human imagination forward. Neptune reminds us that the universe is vast and full of discoveries that could rewrite everything we think we know. It challenges us to keep pushing outward, to look beyond what is easy, and to dare to explore the cold edges of our solar system. Finally, the narrator closes the video by returning to the image of Neptune from afar, glowing in deep blue against the blackness of space. The sun is just a bright star now, distant and small, yet the planet still shines, illuminated by the faintest light, a symbol of mystery and beauty. The video ends on a message of curiosity, wonder, and exploration. Neptune is not just the last planet of our solar system. It is a reminder that there is always more to discover, always more to learn, and always another frontier waiting just beyond the darkness. Through storms, rings, moons, and mysteries, Neptune stands as a testament to the boundless complexity of the universe and the never-ending human desire to understand it.